3D printing on Mars. One way to 3D print is to hit sand or fine powders with a hot laser and then re-screed or surface the resultant material, and you end up with a 3D print in a glassified material. Be it, you can actually use metals and they'll crystallize and they'll glue together, but they're basically sintered, and they often need to be put under compression, heated, frozen. The ones that break under those conditions have structural flaws on the order of the crystals in the metal. But some of that metallurgical post 3D printing needs to be done with certain kinds of metals, but other materials at different temperatures and contamination levels in the air and whatnot, they can have a whole different thing going on. So with 3D printing on Mars, one source material might be the dust storms. Because of the very low atmospheric pressure, the dust that's able to be picked up is very fine and very light. The heavier materials tending to fall out. Now, that being the case, gabion walls might be constructed largely robotically by rolling around on a flat surface and being brought stones and spitting out wired together brick shapes, baskets of heavy steel from wire, and have a conveyor belt come and fill them up with rocks and vibrate them and tamp them and do whatever it's going to take to get them to settle in really nice and tight so they're not going to settle. And raise those walls up not too much of a distance apart, and many of them, such that a person could walk comfortably in the middle. Let's say 7 feet or 2 meters. 2 meters from edge of wall flooring to other edge of wall. And the whole inside could be heavy cut blocks, diamond saw cut blocks. You just use those diamond chainsaws, hydraulic, that they use in quarries and stuff, and you just cut them. Lots and lots of water, right? You bring big boulders into your pressurized areas, which you can do even with a lot of leakage if you build your civilization right and you're doing your infrastructure helps to hold a bubble on the ground, or you pressurize a cave that you can get into and cut stone. There's different options. But you cut these slabs thick and heavy so they'll last for a really long time, and your little robot, just like a golf cart, can drive along and scoop up that very fine dust when it settles and put it into 3D printing boxes as a constant feed-in supply and laser out components. Four minutes. Okay. So, concepts for Mars. One question is, what is the mathematics behind the limitations of materials like industrially high-end produced I-beam custom steel for high-rise buildings, the graphic statics, the load, shear, and torsion testing stuff that has to be passed in order to build here on Earth? What can that technology, what can that knowledge do for us on Mars? What would the standards be for height versus thickness and type of steel? So how high of a building can you build on Mars? You could probably, especially if you had a very wide base that sloped upwards, And you could build an incredibly tall tower. One place that might be good to do that is in the crater of Olympus Mons. It goes up above the atmosphere anyway. And if you filled that whole basin in with a foam I'll describe later, you can basically hollow out inside of that. This is a structural foam. It's foam by definition, not by chemistry. More on that later. Large cell, like 3 meters to a cell. Foam. Compression, torsion, takes it all in flexibility. I got a design, it works. 3 types and parts. Just 3. For the overall structure, the whole thing. So you fill this into this basin. And you build your tower like a tree with roots into that structure as stiffeners that go all the way to the bed, but don't have to cover all that space. And they go up the tower, zippity zoom, all the way up the tower. And that's where you'll be well above the atmosphere. Now, there'd be a lot of questions about micrometeorites and stuff because you have no atmosphere to burn that stuff up. You actually would be legitimately at risk. So how do you toughen the top of the tower? That's a question that answers may come up in the foam discussion because it's the overall architecture for the whole thing. So when we lay out Mars, if we want to make it easier on people to do a lot of work on Mars and make room for our civilization, our global solar civilization, not partnerships, statehood, then we have to have some stuff ironed out, a better plan than the first 13 colonies founding fathers did on overall expansion infrastructure because they didn't have much information. They sent out the Lewis and Clark party blind. That's like landing on Mars with no satellite data, no probe data, just raw cowboys. One thing breaks on the ship, they all die. They can't even radio home like that movie The Martian. Just toast. So what if we have a forward-thinking, overall, infrastructural, limited pre-plan of just leave this particular strips of land alone and the vast majority is available to be more flexible in development? Now, Gabions can definitely help in that rail is going to have a different dynamic with gravity, not holding things down the same. And if we're going to put a wide bed rail through one of those pre-planned right-of-ways, right? Informationally locked in and don't build on it, it's told to everybody before they get there, then that saves a lot of harmed lives and interference in, progress and just general mood of the people. More next time.